Hi students, I just wanted to go over your very last lesson for chemistry. This is crazy. Okay, so this last lesson is all about acids and bases. And I really wanted this to be the last lesson because these are things that you will always have contact with. These things are all over your house, and if you don't know how to deal with them, they can severely harm you. So here are some common acids and bases that you probably see around your house. So we have some cleaning stuff over here. Tide, borax, lime away. All of these cleaning things, they are all considered very basic. That's why they're such good cleaners. We have tomatoes and we have oranges. Anything that's super sour like that would be considered an acid. Now, the fish smell when fishes rot, that is making an acid. So that acidic, gross smell is an acid as well. So there are tons of examples of these things in your house. So let's go over them. So here's the first few examples is a lemon. A lemon is a great example of a common household acid. This is because lemons are very sour. Now, since lemons are sour, that tells us they're good acid. So anything that's super sour is considered acidic. Now, if you eat lots of lemons all the time, which is kind of gross, but if you, let's say you eat something else sour, like pineapple. Let's say you eat pineapple all the time, every day, tons of pineapple. Your gums would actually start to become pretty sore and pretty tender because that acid, that juice from the lemon or from the pineapple would start to hurt your gums. So that's why they start to injure you. Another common thing, well, I hope you guys haven't experienced though, is an ant. If you ever had an ant bite you or sting you, that sting is an acid that the ant was the venom it was pushing into is an acid. So a lot of the time, whenever you got stung by an animal or something, that would either be an acid or a base that it's stinging you with. Here are some other examples. We have aspirin. Aspirin is considered a weak acid as well. We have glycine. This is a common amino acid in our body. You should have learned about amino acid in biology class. And guess what? It's an acid. Amino acid is an acid. And then here are two more examples. Caffeine is a weak base. But interesting is coffee is a weak acid. So depending on what caffeine is in, it can be considered an acid or a base. And then something else people are stung by or hurt by is a sea slug. That puts off acid and that's what stings us. Okay, so those are several examples of acids and bases. Now let's go ahead and define what an acid is exactly, okay? So an acid is anything that has a sour taste. So yes, your sour gummy worms, your sour gummy bears, your sour Skittles, that sourness is an acid. It's actually something called citric acid. So the next time you eat something sour like that, look at the ingredients and you'll see citric acid. Acids also corrode metals. That means they destroy metals. Now this is something you may have seen in like the action shows or something. You see they have a strong acid and the acid breaks through this metal. Yes, that can happen, but it's got to be like a super strong acid. Nothing that you guys would ever be able to purchase on your own. They also are electrolytes, which means they can conduct electricity. So if you remember that conductivity meter we used in class, they will conduct electricity. Acids will. When you react an acid with a base, they do form salts. So when you react the two together, they do form a salt. Their pH is less than 7. We'll go over what pH is in a second. But the big important one is this. Acids produce H+ ions in water. So the main way we know that something is an acid is if I have it and I put water with it, and it makes H3 plus H plus or H3O plus ion, it is an acid. So that's a big key we're looking at. Okay, let's go over what some common acids are. So we have hydrochloric acid. This is your stomach acid. It's really, really strong. Hydrobromic and nitric acid, they are both explosives. Acetic acid, that's your vinegar. You have this probably in your house. And we have battery acid. This is sulfuric acid. You can kind of see this if you ever look at a bad car battery and you see some of the battery juices like seeping out of the battery. When mechanics touch this stuff, they're very careful to wear gloves because sulfuric acid can severely damage you because it's a strong acid. Now, if you look, all of these, most of them have H's in the front. Having an H in the very front of your formula is a really good indication that it is an acid. Okay, let's look at some properties of bases. So bases, they have a bitter taste. So that could be like your dark, dark chocolate, super bitter tasting. They are slippery when you touch them. So think about like your soaps or cleaning materials, or Windex, Lysol, 409, bleach. All of these are really slippery when you touch them. Now, why is that? That's because those bases are damaging your skin cells. So they are killing your skin cells. So as you slide your skin cells around, you're literally killing more and more skin cells, and it's becoming more and more slippery because you're sliding skin cells around, dead skin cells. That means you're killing your skin cells. So whenever you come into contact or clean with any of these cleaners, wash your hands afterwards because that slippery stuff isn't good. That's killing skin cells. Their pH is greater than 7 and they give off OH. So acid gave off H3O plus, bases give off OH. And they turn red litmus paper blue. So here are some other common examples. We have hand soap, lye, baking soda, bleach, spinach, window cleaner, a wasp sting. All of these are considered bases because they all give off OH. Now here's some fancy name for bases. We have sodium hydroxide. This is a fancy name for lye. Potassium hydroxide. This is your liquid soap. Now it's not super, super basic. It's not going to hurt your hands and stuff like that, but we do use water to wash it off. We have barium hydroxide, that's a stabilizer for plastics. We have magnesium hydroxide, that's milk of magnesia. You can actually buy this in like the grocery stores, and some people use that for indigestion. Interesting. And then we have aluminum hydroxide, which is an antacid. Now think about this. Your stomach has tons of acid in it, right? Like super low pH, super strong acid. If I add something basic to it, like milk of magnesia or an antacid, they're both basic, they'll kind of help calm down and neutralize your acid in your stomach down. Now, you shouldn't do this if you're not having issues with like stomach acid and stuff. That's only for those who are suffering with like severe heartburn or stuff like that. Because having your stomach super acidic is really important to have a healthy life though, because that acid destroys bad viruses and bacteria, breaks down the food. So it's good to have an acidic stomach, but if it starts to give you heartburn or stuff like that, that's when sometimes people take something slightly basic to kind of calm down that acid so it doesn't hurt as much. Okay, so don't forget to take the quiz right now on the Nearpod, okay? Okay, let's move on. Here are some acid and base definitions. So there are several definitions out there of what acids and bases are, but we're going to focus on one mainly. And this definition is the Arrhenius definition, and it's what we kind of went over already. And it's the idea that acids produce H plus ions, or H3O plus, same thing, in water. So whenever I have an acid and I add water to it and it makes H3O plus or H plus, that's an acid. Bases, when I add water to it, they will make an OH minus. So those are the big differences. So you're going to look at the products and see what did it make when I added water to it. Did it make H3O plus or OH minus? So here are two examples. I have HCl and I added H2O to it. Now I'm going to look at the product. My product is H3O plus and Cl minus. So I can see that when I added H2O to it, it made an H3O plus. That tells me that HCl was the acid. Now here's another example. I have NH3 and I added water to it. It looks like I made an OH minus. So this OH minus right here tells me that I started with a base. So the base was NH3. Your water is just here to kind of kickstart the reaction. The water is here to break down the acids. Okay, so when you're looking at this, you're looking at, does it make an H3O plus or OH? And depending on what it makes, it is either an acid or a base. Now, I kind of talked about this before, about neutralizing acids and bases. So you can neutralize them out. Now, what the heck is neutralize? So neutralize is when you add a certain amount of acid and a certain amount of base, where they kind of cancel each other out and they become neither acidic nor basic. Now you have to add the right amount. If I add way too much base or way too much acid, they're not going to cancel each other out. You have to do some calculations to make sure you add the correct amount so they neutralize each other out. Now you guys have done this before in class. Whenever we did a lab with a strong acid and you guys spilled a little bit, I had many of you pour baking soda on those drops on the countertop. And you'll see it bubble like crazy, and then I had to just sweep it up. What you're doing right there was a neutralization reaction. You had a strong acid, and we added some baking soda, a base, and they cancel each other out. So now it is neither acidic nor basic, so it's not as harmful. Kind of cool. Okay, let's jump into what pHs are. So a pH scale is a way of expressing the strength of an acid or a base. So if I say, oh, it has this pH, you can easily know, okay, that means it's super strong or it's super weak. So here are the scales. So 0 to 7 would be an acid. 7 is neutral, not an acid or a base. 7 to 14 is basic. So if you look at this scale, it's kind of cool. It shows you different examples. So for example, your stomach acid is a pH of 2. So the farther you go down the pH scale for acid is strong. So 0 pH is very, very strong acid. Whereas 14 pH is a very, very strong base. So right here in the middle, at 7 is when they're neutral, neither. But as you go either up or down, opposite sides, you become stronger, either basic or acidic. So 0, very strong acid. pH of 2, still very strong, but not as strong as 0. Lemon juice is actually between 2 and 3. So it's still pretty strong. Vinegar is a 3, we keep going up. Weaker acid. Milk, that is a 6.5. And then it gets neutral. Blood is slightly acidic. Then we keep going up and up. More and more basic, okay? So 7's neutral. Going up from 7, becoming more basic. Going down from 7, becoming more acidic. Now here are some common substances you'll see. So vinegar, so pretty acidic. Soda, it's also pretty acidic. pH of 3.8, pretty acidic. Blood is slightly basic, 7.4, barely basic. Because 7.0 is where it's neutral. Ammonia, oven cleaner, these things are all very basic. And there are a few different ways, I'm going to go over this real quick, to test a pH. We have litmus paper, a pH meter, and a universal indicator. All of these, the first two will change color depending on your pH. So if it's really basic or acidic, will change color. pH meter will just tell you your exact